Hello everyone, my name is Kazwe Julius, and today I'm making a continuation about the handwritten digit recognition problem that we've been discussing in the previous videos. And today we are going to be majorly talking about the AI environment and agents together with the search algorithms that you're going to be using in solving this problem. And we shall be talking about the informed and uninformed search algorithms and their applications, plus the AI accountability and unwritten digit recognition problem. So my problem statement is provide a comprehensive of real-time recognition of unwritten digits in images, paper, documents, screenshots, and other sources where we are having digits that are handwritten. So an AI environment is the surrounding of the AI agent. And since when we talk about AI, we majorly look at the study of rational agents and their environments. So it's very important to look about these two aspects. So the environment is the surrounding of an agent. And for an agent, is anything that makes logical decisions according considering the past and the current aspects. And for the agents, they can be people, software, machines, like robots, anything that makes logical decisions is an agent. So the environments these agents act in are what is surrounding, or what we can call the surrounding of this agent. So there are several types of environments which can be described according to their features in the view of the agent. So in my project, I intend to be using an environment that has such descriptions. It will be known, first of all, to be discrete, to be static, fully observable, and deterministic in nature. So according to these descriptions, that's how I can categorize my environment. Therefore, it will consist of a finite number of known actions that can be that can be done in this environment to obtain the output. So since our environment will be known, for example, we shall be using images to insert data into our AI for scanning and detecting these digits. We shall be having a given set of actions, say scanning and maybe searching for the right digit to predict. So there will be a finite number of known actions that will be done in this environment, and they will be mapped to a given output. So if you're scanning maybe a digit 4, which is handwritten, it will be mapped to a digital form of 4, number 4. So we shall be knowing the actions that are going to be done in this environment. And our environment shall not change while the agent is acting. Say our agent, maybe it's a mobile phone and it is maybe scanning the image where this digit is written. The environment from which we are scanning this digit will not change when we are doing the action of scanning. So the environment will be static in nature, will be static, and the agent can always see the entire state of the environment, which will make our environment fully observable. Since at the time of action, this agent will be able to determine the set of the environment. Say if maybe you're scanning a number, maybe 6. If an agent, maybe say our mobile phone, is tilted at some angle, that alone can determine the state of the environment. Since if maybe you scan the image upside down, you might get a different figure. If it's a 9, our system may predict a 6 if you tilt the phone to be upside down. So the agent does a lot in determining the state of the environment. So, and with that characteristic, I would say that our environment is deterministic in nature, since the agent the current state and action of the agent can completely determine the next state of the environment. Yes. For the AI agent, as I've mentioned before, I'll be using entirely software for my agent and machines, say phones, because the system will be maybe installed in a phone and shall have given predetermined actions which will be done in these machines or software. So our agents are, as I've defined before, is anything that makes logical decisions according to or considering past and current aspects. So our agents perceive input from the environment and they output the results to the environment. Still, they respond to the environment. So they do the perceiving through sensors and they output through what we call actuators. So for our AI system, I'll be using a software agent which has keystrokes. Say we shall be having maybe buttons that will be maybe telling our system to upload a file to be scanned. So we shall be having keystrokes. We shall be using file contents. We shall be uploading files of images, files of screenshots. Yeah, and the keystrokes with plus the files contents will be acting as our sensors. That's where our system will be scanning the input from, and after predicting whichever digit that is scanned, we shall be displaying it on the screen, which will be acting as our actuator. So since my agent will focus on the goal state, it is classified as a goal-based agent, and the decision took by the agent will be based on how far it's currently from their goal. So since we shall be mapping our data to a given result, say if you scan a 4, I'll train my system with a different 10 digit characters, 0 to 9. So I'll be having like 10 classes of digits. So since I'll be having a goal of achieving the right and most accurate answer when I'm scanning digits, our agent is intending to be goal-based. So we shall be setting a goal to our prediction of solutions. We shall be mapping predetermined or trained. We shall be mapping the training images of digits to the intended output of digits, digital digits. So with this, our agent has an option of choosing from multiple possibilities. So our agent will be having an option of choosing from a given set. So it will be making predictions from a set of from a multiple of possibilities that are predefined in our model. And for the goal-based agent, this is how they perform their task. So they taking the input from the environment through the sensors, and our sensors are the keystrokes and file contents, and then they will take a look at whatever is in the file, say the image, then they compare it with what is already predefined on what or how the model will be trained. So they will compare with whichever data will be having previously in memory, and then they try to do a certain action. So if say I'm scanning a number 6 from an image, this agent will be taking a certain action, say A, and after, according to the given goal or mapped digit, it will be able to react and display that intended digit that will be in the image according to the already predicted goals or set goals in our model. So for the data set, I'll be using the MNIST data set, which is a very famous data set that has about 70,000 black and white images of handwritten digits. And among these 70,000 images, 60,000 of them are training images. So these training images will be used in the training, will be used for training our model, and the 10,000 will be used in the testing or verifying our results. So each image is made of is a 28 by 28 matrix. So in total, it has 784 pixels in total. Each small image in this data set. And for each pixel is encoded as an integer from 1 to 255. So 1 being completely white, and then the 255 being completely black. Yes. So the informed search and uninformed search, these are algorithms that are used in solving our problems. So these are such algorithms that are used to search through the problem and find the solution to the problem. So the informed search algorithm has information on the goal state. For it, it is informed, or it uses experience to solve problems, which makes it more hopeful in such a way that it's more efficient, quick, and gives accurate searches. Examples of these algorithms, the informed search algorithms are the grid search, the S-star search and the hill climbing algorithm. The informed search uses knowledge for the searching process with a low cost from the root state to the goal state. Therefore, there is a direction given about the solution. So it already knows the path to take when it is searching for the solution to the problem, or when it's aiming at the goal state. It knows by the time it runs from the root state, it knows which path it is supposed to take to reach the goal state. It's directed. It has knowledge about how to go about the problem and find the solution immediately, so it's quick. And the informed search, in contrast, it has no prior knowledge. It has no prior knowledge about the goal node. For it, it is only provided with basic knowledge in the problem definition. It only knows maybe the order and the length of the action that's supposed to take. So for it, it has actually it has examples of the uninformed search algorithms are the depth first search and the breadth first search. And there's also a combination of these two, which is called the uniform cost search. So with an uninformed search, there is no suggestion given regarding the solution. So by the time this algorithm is starting to find out the goal node, it has no directed route or path, defined path to the solution. So it has to find it out by its own, by aiming at the goal state. So this uninformed search for it, it aims at the goal state, not following any path or any knowledge of where the solution could be. So for the AI accountability, what I understand by this, it could raise a question actually of who could be responsible or accountable for the consequences that may arise when an AI system misbehaves, or if it drifts away from producing the accurate and fair results or the expected results or the intended results. So who is responsible about this AI system when it fails to perform the intended result? And actually, it's a very subjective question to answer. It's upon whoever is taking in this question. And it's very hard to decide whether we should maybe take the blame to the user, because users maybe may intend to use the system in a very different way, which wasn't intended for by the creator. The person who created the system might have created it for something else. Say I have created my digit to scan digits, to scan maybe checks, scan to help us scan uh, post no letters, but then the user uses it in a in a biased way. Maybe they use it to scan people's credentials, which they're not authorized to do so. So it's very hard to decide whether it is the user or creator or the vendor who's fully responsible or accountable for the consequences that arise in the misuse of the AI, or in the inaccurate or unfair results given by the AI system. So the AI accountability means that we have to take note of the transparency, and we have to make sure that our AI is explainable and it gives a fair meaning which has no unintended and unacceptable biases to the society. So we need to give much attention to some areas when we are developing the AI. So we need to give attention to the functional performance of our AI. So the data, we have to take much attention about the data the AI will use and how the system itself is used. So all the components within our AI need to function properly for the system to produce accurate, fair, and legal decisions by technologies, say machine learning. So we have to use technologies such as machine learning, and we try to come up with an AI which functions properly and produces accurate and fair as well as legal decisions which are not biased in any way. So we should use machine learning to come up with such a solution so that by the time we put up this system on market, we're already assured that it's not going to give biased results. Rather, it's going to perform legal decisions and actually give us accurate or fair results as we expect it to do. So we should also actually ensure that a high volume of quality data is used when we are training and using the AI. So, and should take note that AI systems work best when they are trained very well. And with the training, we must use clean and unbiased data. So the data we use when you're training our models should be clean, should be on point, should be over intended purposes. So we shouldn't include any other, but we shouldn't include any unbiased data. Shouldn't include unbiased data to our training data set. So that's why in my model I'm going to be using them in this data set, which only deals with the 10 digits without any biases, because they're just small images which are in black and white. They don't have any color. They don't have any credentials in them. They're not in any pattern that maybe we're using someone's account, someone's telephone number as our data set. So we are only using a single digit image to train our model. So it's not biased in any way. We don't use any person's credentials to train our model. So therefore, that's how it should be for the rest of the AI systems to work best. Should use clean data so that whichever person looks at this data or uses this AI doesn't use it for the unintended purpose or for their own good. So the other area to tackle when we are targeting AI accountability, or when we are targeting the AI morality and good behavior, when you're using the AI model, we should ensure that the data fed into the algorithms, and actually the algorithms themselves shouldn't be discriminating. So with this, we shall be preventing the unintended biases too. So we have to ensure that the data fed into the algorithms as well as the algorithms themselves don't discriminate. Say you're building maybe a model and you're involving tribes, so you shouldn't involve any kind of biases. It should be generalized. The data you're using should be of shouldn't be discriminating, pointing at a given group of people. It should be a generalized kind of data. If in case of this handwritten recognition problem, I'll be using the in this data set, which surely just uses numbers, 10 numbers which are classified into from 0 to 9 single, and each image contains a single number. So it's not biased in any way. No person can take offense of such an AI or algorithm that takes in such data. So with that, have a nice time.